Guys, my name is Dixmeister. I'm a self-employed web developer. My company is called Teamocom, and I'm based in Vienna right now. I will give you a short introduction into Scala reflection. It will take about 15 minutes, so I hope this is okay. The agenda is what is reflection, then the Scala reflection universe, the mirrors, which are the information providers for reflection, symbols, and at least some examples. What is reflection? For people who don't know what is reflection, it's the ability to inspect and possibly even modify itself at runtime. There are three types of reflection in Scala: runtime reflection, compile time reflection, and verification. I will only talk about runtime reflection because I don't really know the other two types, and probably it's not enough time to talk about. Scala's reflection panel was introduced in Scala 2.10. Before that, it was only possible to use Java's reflection. So, the entry point to Scala's reflection is the universe. It provides an interface to all main types which you can use, which are divided into types, symbols, which presents definitions, trees, names, annotation, constant, positions, and flag sets. To import this, you need the Scala.reflector.runtime universe, and you might need some more stuff from this library. Mirrors are the information providers of reflection. So every information is provided by this reflection and made accessible through these mirrors. There are two different main flavors of mirrors: these class loader mirrors and invoker mirrors. The class loader mirrors, they translate names to symbols, and the invoker mirrors, they are most commonly used. With this you can inspect and invoke objects at runtime. You can obtain these invoker mirrors or special invoker mirrors from class loader mirrors. There are different types of mirrors. There's the reflective mirror. It's a class loader mirror. You can load symbols by name, and it's the entry point for invoker mirrors. With instance mirror, you can create invoker mirrors where you can invoke objects and reflect methods, values, whatever. Method mirrors is for invoking instant methods. The class mirror is invoker for it's a mirror for invoking constructors of classes. The model mirror is to get singleton instances of objects, and there's also a field mirror where you can get and set instance fields. The symbols are the bindings between the name and the entity it refers to. So everything which you can give a name in Scala is represented through a symbol. There are two main symbols: the type symbols, with handles the type, class, and trait declarations. For example, a class symbol. And there are term symbols, which handles value, variables, definitions, and object declarations. For example, a method symbol and a module symbol. There's also a free symbol type or a free term symbol type, which you can use if you don't have all the information at compile time. Yeah, short example how to use it. First, you need to obtain a runtime mirror. You get this by the universe function runtime mirror, and with get class loader, you get a runtime mirror of the current class loader, which made all types and symbols visible to you. Next one, you need a class symbol to reflect the class. Therefore, class, and you can reflect this class, or you can obtain this class symbol by the type of function and this type symbol. But you can also do this if you have a value, which is maybe not typed, by a function like getTypeTag, which returns the type tag of the value. Therefore, you can use the type member of the getTypeTag function or of the type tag to retrieve the class symbol. With the class symbol, you can reflect the class with the runtime mirror, and you get a class mirror. Same thing for object. Object is defined, and the only difference is that it is not casted to a class symbol, it is casted to a module symbol, which is a term symbol and not a type symbol like a class. And yeah, you can reflect this via the mirrors reflect module method. A practice example how you can use this, for example, to invoke a constructor. Here is given a case class. First, again, updating the runtime mirror and getting the class symbol and reflect this class. And then you can use the declaration method of the reflect type, where you can get or obtain methods and terms. This universe ME constructor is already a constant, so it's a constant term with which you can invoke the constructor. With the class mirror, you can afterwards reflect this constructor and call the function with a parameter. The result you get is the reference class. You can invoke a class by instance and the object too. So once again, getting the runtime mirror, and this is another way how to get a class symbol by a name. So you can use the mirror static class function or the static module function to get a class by name or class symbol. In case of a class, as you see, you have to use the companion symbol and cast it to a module symbol that you can get a direct instance of this class. For objects, you just have to reflect the module and obtain the instance. Yeah, you also can reflect a method or call a method, invoke a method with reflection. First, a little example, defining a value of type list, and if you call the function take2, you get the first two entries of the list. You can do the same with reflection by, again, obtaining the mirror. If you already have a runtime value, you can also reflect this instant mirror via the mirror reflect method. And yeah, to get the method symbol, which you want to call, you have to get the type signature of the reflected instance mirror and call the method term, which is done via the member method and creating the new term name tape with the function name and cast it as method. Yeah.
Well, I will ask at the end. Sorry.
Okay. If you have more methods with the same name, you can also get it with STM alternatives and choose the alternative method which you want. Reflecting the method is done via the instance mirror, where you can reflect the method. The result is, no surprise, same as the first.
This alternative is, so this line at the bottom is like the 5 lines.
Yeah, it's an alternative to, no, it's alternative to the reflect to get a method symbol.
Ah, okay.
You don't really have to do this via the instance mirror. You can also do it via the type tag and this declarations function.
Okay, yeah.
Yeah, that's it. Any questions?
If you go,
Any further questions?
the mirror, my understanding of mirrors, or no, those are manifests, or because of type erasure. I don't know in English how to pronounce it. That in the JVM, all the type information, the compiler.
Erasure. Type erasure.
At compile time, my understanding is that the type information is erased.
It's erased in Scala August.
But I didn't hear anything about manifests here.
Because the type text?
The type text are used to get information.
Type tags are manifests, basically. Manifest is just one kind of type tag.
Type tags like an
So manifests are just
Yeah.
one type of type tags.
Yeah, yeah.
Okay.
You get the information from a class
Because
to a type.
They're new type tags.
Type tags are new because in 2.8 there were only the manifests, and from 2.8
Okay.
about the use of type.
So manifests are going.
No, they are still there, but they are deprecated or obsolete or.
I think there's, I can't remember which one. But
Can you talk? Do you hear from there or?
I remember reading there's a function that is still only fulfilled by manifests, but I couldn't tell you right now what it is. I mean, manifests are staying, but for what you used to use manifests, you should use type tags from now on.
Okay. Good. Thanks. Any more questions?
Yeah. Since in the introduction you meant you're basically a web developer, what was the use case that you started diving into reflection?
I'm nothing special. I just
For fun.
started with Scala development about 3 months ago, and it was an example which I was looking into.
Do you know why these classes are all called mirrors?
No. I don't know why they're called mirrors.
I think they act as a proxy to the real thing, and they provide a reflection information. So they mirror an instance or a class or whatever.
If you want to see a reflection, you have to look into a mirror.
That's a good explanation.
So have you been using Java reflection? If you
No,
compare this
not
to
at all.
no?
I just have done a little bit with PHP reflection, but that's it.
So you were interested in reflection because you have used reflection before in other languages?
No, not really. It's just about looking at how you can modify objects at runtime, and this was the result.
And now that you know how to do that,
I don't know what to do with it.
it's a solution looking for a problem.
Has anybody else a use case for Scala reflection in this experiments at work? Or?
Yeah.
You?
Yeah.
Take over all use cases from Groovy. Just a joke.
For a while, it was being used for JSON deserialization quite a bit in the early libraries, and that's being replaced now with macros.
Yeah.
But there is 5 or 6, I can't remember, JSON libraries out there in the Scala world. So now there is a 7th one called JSON 4S, named after the login facades and what's a lot. In Java, I've got too many of them. And there is another thing called pickled Scala signatures. So it's something that's being added at compile time to the compiled bytecode.
The pickles.
The pickles.
Yeah,
Pickles,
from